Hi all, so welcome to another day on this JMeter journey. And as a recap, so till yesterday we have finished up to like discussing of time function, then the scenarios of hotel booking, hotel cancellation, then some scenarios on some other products as well, right? And some other product to practice. Right? Now, today, as I said, there was one special case which I'll be discussing, which is logging. And in that uh, will be also understanding about synchronous and asynchronous. Fine. So, to discuss this, what we'll do first, I will do a recording of uh, mm, yeah, this Snope Commerce admin panel, okay, and then we'll try con. If you do that. Now, I'll do from Mozilla File. So only two transactions. First is launch and then login. In login only we have to understand some concept because those concepts can repeat on some other application. So that is the main point to discuss. This is T01 home page. Uh, Just verification. Okay, so many. And then Mozilla Firefox will also throw error. So many. That is also fine, but I want to have press. We'll do it again. Now, second T02. So, you see, this page is still loading. Now it got fully loaded. We have to wait till page gets fully loaded, right? And that's why that compulsory wait of 5 seconds. So this is login. We will just do this much. There are many other things you can just explore, and if you want to practice, or you can practice, or let it it's the main page which I've shown yesterday, right? Commerce page, some phones and other things were there. You can use that to practice. This is for one special case. That's why I'm using. So let us stop. Again. It's not required. Okay. Now, what is important, right? So let us. This is home page. Fine. And this is the request. Okay, so I'll parallel show this here. So homepage is very simple. This is homepage. So this is homepage, and we have one request. Okay, so this is the and this is the response, obviously, and then there are some uh, embedded resources retrieving that is there. Fine. So this page also looks simple. Now, next is login. Okay. So we'll do the log. Now, when we do the login, so on top only you see three calls are there. And if you see there, see the sequence. So for two redirection, and this is the main. So I think this I have covered in last session as well and explained this. That sometime only two redirection happen means first redirected, and from there their second one will be the main one, right? Sometimes two-time redirection can also happen. So here are two-time, it's getting redirected from here, and then it's getting redirected from here. And this is the final one, right? And that we can see in waterfall model also. So in redirection concept, if you see, always see these calls are called synchronous. Synchronous means they are dependent on each other. Okay. So only when first get fired, and you see it got fired here and it's finishing here. Then second one is just starting from here and it is finishing here, right? And then the final one, this is starting from here and it's finishing here. and here it is bringing the response because this is the main one, 200 one. After two redirection, this is the main call, right? So what we are understanding, right? So you see, one after another, they should be in sequence. Okay, they should be sequence, and they should be dependent also, right? They are dependent on each other, correct? One after another, and the dependency is there, and we see the dependency here as well. The first request has carried the payload. You see here, the payload, which is email, password, and verification code. Okay, now, and it is a post request, obviously, uh, because it's carrying the payload, so it will be a post request. Now, uh, fine. So from here it got redirected here, and so this three is fine. Okay, and we understood that. So this kind of thing will be like synchronous, means they are dependent. Right? So it will never happen that you directly fire this. No, if you fire this and then you can miss this, because and this request is carrying the payload. The username password is with this request. Then it is redirecting to this request. Then it is getting fired. And then it is redirecting to this request, which is getting fired and bringing the response. Response always comes in the 200 one. Right here is the response. The redirecting request will never be having the response, right? So this is the concept of synchronous. Now asynchronous will be downside. So I'll be covering them. First, let us fix it out. So this was home page, simple. Then we had a login screen. Now in login, we had first request, uh, post request. This is the email, password, and the token. Then this is another request, the second one, right? So we can say we can rename this as login one, login two, login three, right? So and this is the third one, the main one, correct? Right, one, two, three, fine. And yeah, if we want, so if you want to do correlation for this stuff, you can always do. And username password for multiple user, you can pass from test data file, but that is not the purpose of doing performance testing here. Here we have to understand the script. Scripting is main, right? Other thing are just after, means once the script is ready, then we do other thing, right? So that all you know. For now, I'll just do the correlation for this. Let me check. Control should be in 51. It's there in 40. So it's passing in 42. So the rule, right? Like always in previous requests. It's here. This is the value from here to here. So we will take from here. That's left boundary, and this will be the right. Right. Two such values come, and both value are same, I believe. Match one, match two one. Yeah, means this value is there in response two times. So in that case, we can take anyone. Both are same. Both value are same. There is no change. Both are same. So it can happen. Right? So it means that this value is repeating two times in the response. So in that case, we can take anyone. We can take match one. So now add stuff. So, So match number is 1. Uh, Supposed to do the replacement. Control F. Control V. Replace. So that got replaced. Okay. So this value got replaced. Now, if I run till year 1, so the other login form disable. You can just log in to that point and check. Manager is important. It doesn't. Cookie manager always calculate. So very important element to add, right? Even we did everything correctly just now. Again, I'll repeat it because cookie stores the session. So suppose I'll toggle cookie manager and same login will again fail, right? So that time, so you see that is cookie so much important, right? This is because what happened when homepage launch has happened, that time only in response, there will be some cookie value coming from server side, okay? And that has to be passed, maybe this one or something. So many cookie are there. Anyone needs to be passed back in other subsequent request, even though everything is correct. Then also, right? There are no cookies. And if I enable this now and run same, so now see, yeah, cookies are being right. And these cookies, anyone you take, so many are there, but suppose anyone, suppose this one only. So it is there in the uh, response header of the home page. See, let's see, right? Like that. The cookies are big. Then there is one cookie here, NOP anti forgery. Yeah, this is another. Okay. So this is cookie, and I think I've explained this how cookies work. So first time when anyone launches the say, launches the website, the first the cookie will be coming from server, right? And then they get stored, and then with every request, that cookie also needs to be passed back. If you see, with every request is passing. So dynamic value is different thing. Dynamic value has to also pass, and then cookie has also need to. Otherwise, if anyone, suppose dynamic value is not passed, okay, or let us do some error in the dynamic value. So now cookie will be passing, but I have done some error in dynamic value. You see, dynamic value is not correctly passing, right? So it's also failing, right? Because I did some mistake in this dynamic value. Stuff now rectifying. Now, if everything is correct, then all good, all goes good. Then suppose everything is good, but cookie manager is not there and cookies are not passing. Then also it fails. Cookie I have disabled. So see, it's failed. So see, both are important. So that's why this aiding cookie manager was there on my first point in the PPT before doing the correlations. Fine. So we did this, right? So so login is happening, and you can see here. This is 302, 302, and here 200. So we will be getting response here. And in response, you can also see it will be showing as login, yeah, John Smith and logout, right? Which is here as well. You can see John Smith and logout. So proper login has happened. Assertion and another thing, I'm not going to do all those. Here we have to just understand some concept. So this is done fine. Now next is, if you see there are two more login transactions. And if you see in them, there are some requests. So this request is Google here. This is WFF2 means embedded resources. This is also. So this whole we do not need. This all we do not need. So this I'll delete. Fine. Now this is the log. Now here if you see, okay. So here also by looking at the request only, if you see this all are OFF2. OFF2 are embedded resources. So we can delete them. We can verify here as well. G static and OFF2 not related to our application. So all three. This you see JSON, 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 and this all are related. This many. You see, this many additional requests are there for login, right? Now, from where they are coming? Okay, so they are responsible. I may have shown this long back also, but I'll tell you. So here also, if you see downside, if you just put this all XHR requests. See here, so many here, and then here also. So number.json currency.json.json. These are right. So the JSON file, and then here this is also there. Then get order average, all this. All so this all these are those. Okay. So you can see all JSONs are here. So all JSON here. And then here load static, load order static, load customer static, and then get order average incomplete. All this, right? This was still here. So it's here too, right? So how many are there? I can count. I think there are probably 15 to 20 are there. Okay, 15 to 20 are there. So now you see a login, apart from having 3 requests, it is having this many 15, 20 requests also, which are downside. But these requests are these 3 requests are synchronous. They were dependent on each other, right? If anyone you do not run, then a login will not happen. Correct. So this is dependent. This is dependent on this. This is dependent on this, and they have to run in a proper sequence, one after another. Correct. But this logins call are asynchronous. Now, what is the meaning of asynchronous? They are not dependent on each other, and they had to be fired parallelly. Okay, parallel concept. So first we'll understand that what they do, right? So if you see on this same page, if I go downside, you'll see this this table size, the order table or the new customer table or total order table, incomplete order table, right? Latest order, popular search keywords, bestseller quantity, bestseller by amount, right? And in every table, if you see, there are values. There are so for every table, these values are fetched by these requests. Okay, this request. We can match anyone. Suppose latest order. So do we see latest order? It will be there obviously, but it can be in some other format. Wait, let's first see this one. Uh, Bestseller by quantity. So it's here. Bestseller brief report by quantity. I think this one. And if you go to the uh, response, so what you see is the 16 Leica mirrorless. It's amount. So here Leica mirrorless, Apple Icon, Apple Icon, Levi's jeans, right? So whatever data are there in this total 12 data are there in this bestseller quantity table. So all data is and this is fetched by this request called right? This is the request. Okay, this is the same way by amount. So for this table, whatever the data are there, this is fetched by this by amount. Okay, request and you can see the response. Here also vintage style engagement ring, the like a mirrorless, flower girl, bracelet, all are there, right? So like that. So for every table, there will be for latest order also there will be some uh, one request will be there. Then incomplete order, order total somewhere they here you can see incomplete order is there. Right? In any one of this here order incomplete total. Mhm. See all this data matching, right? So that is there. Then for this also it will be maybe this one or this one. It will be there. So no need to go in that. I'm just making you guys understand. So you see on this page tables are there, and for every table, this data has to be called. Okay? And this requests are being separately made to call those datas. Okay, to call those data. Not an issue. I'll just refresh them. So to call them data, there will be so many tables here. Okay, and for that, so they are I cleared them. I just reload it again. You see downside. You see data are not there on this table, right? Do you see? Now data are coming slowly. Initially data were not there, right? It was. Well, I'll do it again. Just focus. Like I'll go down and you'll see for this table initially data will not be there, and only when those calls will be fired on here, when slowly data will be loaded in this tables. So initially, you see here these tables are there, but no data. Now slowly data are getting populated. Correct. Again, shall I do one? We'll just focus. See here, no data, and now slowly data has came, right? Because this calls got fired again, and they fetched the data. So these are additional call apart from the main call, which was the three call above, right? Now these calls are not dependent on each other, and hence they are called asynchronous calls. And if you want to see that why they are not dependent, so if you see they are firing time, so they are almost fired at same time. See this one also after some time, but same time. It's not like that one after another. It's not like that, right? Like above three call which I shown previously, which was here, they were firing one after another. correct? So that sequencing is important. Here they had to be fired at same time. That is the main thing, right? So we have this same, all these calls are here. So hope you understand about this call. Now we will bring all these calls uh, to inside login, because login is the only one. We'll be putting them inside login. So these three are the above calls, and this below are the rest of them, right? Now, before I go and show you how they runs, let us do some stuff, some other stuff. So in any of this request, does any dynamic values there? So here is one dynamic value. Now, what is this, right? What is this value?
Epoch time.
Uh, so this is epoch, right? Which we discussed uh, just one day back, right? So how the and this is dynamic in nature. This is always changing, and you cannot extract this, right? Because this value will never occur in response. You cannot extract. And this value, because this value nature is something different, right? It always regenerates itself depending on milliseconds. So how to handle? First, you have to count whether it is 13 digit or 10 digit, right? So generally, I think this is 13 digit. 3, 3, 6, 9, and 4. Yeah, 13 digit. Okay. So if it's 13 digit, then it's very simple. We have to go to the functions tab and bring this time function. Click on simply generate. So this is the time which will generate the current 13 digit epoch, right? But if it is 10 digit, then what you'll do here, you have to give divide by 10 and then click on generate. So whatever the function will be, that you will be using. But here is 13. Generally, it will be 13 digit. So now instead of this value, and plus control F also we cannot do, because if you see this value, it will be there in some other place as well. This is in 67. Let us see some here. 68 also it's there. 60, 75 it's there. Downside it's not. So it's there in 75, 68, and 67. Now if you see the value here, it's 5791. Here it's 5790. Sorry, here it's 5791. And here it's 5792, right? It's completely different. So we cannot do that control F as well to replace them in one by one. We have to do. So what we have to do, we have just copied that value, right? So simply just copy that and control D. So it will be replaced by time function, and automatically instead of this value, the current epoch will be generated when this request will be firing. The current epoch will be generated. Right? So this is how we will be handling time epoch. Right? Time we know yesterday I explained then in our adapting to hotel booking. Next, here there is one another request verification. So that we will do correlation. So this value will be in 44. I know, but I'll tell you. We can do. So what is the rule? This value is passing in 78. So 77, right? 77. Just passing in 77. So the rule is generally first you go and find in 75. Control A, control C. So let us go and find that in 75. But it will not be there. This is the response of 75. It is not there. Paid is coming. It's not. So now where to find, right? So one by one, if you go and find in 74, 71, 73, it will take long time. Directly you do global search. Put the value here and do search. So put the value here and do search. So now you see that these all are highlighting. So this value was passing in 77. Yes. So 77 is getting highlighted. And we do not have to look after, right? No, you have to always look back. So scroll up, see somewhere it is there or not. You see it's in 44. Okay. So sometime it can happen that from 44 the dynamic value is coming and passing, right? So that happens. So now say so, same means the expression will be same which we prepared earlier. Same here also 2 time it's coming. So anyone and both value are same. So anyone we can pick match one only. So this already we have done in home page also it was same, right? And it was passing here. So now same thing when this is also same. So yeah, both same. So what I'll do, I'll just copy this and put it in 44 here. We'll just change the variable name. So this is going to be expression is same little bit. So variable name request verification token 2 here also will update 2. Also will update 2. Why 2? Because this was the one, right? Which was, and now the same with same name there is another value downside. So now we are doing that. Now we'll do control replacement, control C, control F. This so this is the variable 2. What is the value? Value is somewhere here. This is the value in 77. Yeah. So that value is there in multiple requests 77, 78, 18, 19, whatever, all everywhere it got requested. Okay. Now, this fixing is now what is a special that we'll be discussing, right? So one is epoch time that we discuss. Next is running them. Okay. So see, that is the main understanding. If you see here, let me run. Generally, when we run always, so a request fires one after one, another one is using one after another. These all requests are getting fired one after another, right? In how they are arranged in the same way. Now, problem with them, like these three requests, we know they are synchronous, so they has to be fired one after another in sequence, first, second, third. That is correct. But all these are asynchronous calls, so they do not need to be fired in sequence. First thing, second thing, they has to be fired at same time, right? If you see the starting time, same. But here in JMeter, if you see, this is getting fired at 408. This is 08. This is 09, right? Fine. This is 09. Then this is 10, right? So every two requests, there is 1 second gap is there. So it's not at same time, right? Do you see? So this is getting fired at, let us say, 10 p.m. 04 minute and 12 second, right? And the first request was fired at 10 p.m. 04 08 second, right? So this is 2. You see the gap between these two, 4 second gap, right? So is it correct? It's not correct, right? Even the last request, if you see, it will be getting fired at somewhere 28, 17. So 10 04 17. So first request got fired this and last request got fired at this. there is a gap of 9 seconds. 9 seconds, right? But that is not the scenario. This calls has to be fired in same time, same time. But now when we are running, it's not happening, right? And it's taking total 9 seconds only from here to here. Only the firing time gap is 9 seconds, right? Which is not good. So how to solve this? Correct. So since these calls are asynchronous, why they are asynchronous? Because we can see by looking at this only, we say a synchronous call will only fire always one after another, one after another. Okay, a synchronous call will start from here, will end here. Suppose then another call will start and end like this. So it will be one after, right? You see, one after another. But asynchronous calls, calling time, you'll see they will be always same time, right? So same thing we have to simulate. That way you'll come to me, right? And here you see, just now I've shown you that there is a huge gap. First request, whatever is passing at whatever time, let us say, and last request gap, like total 9 second gap. Means first request sequentially they are getting fired. So obviously time it will be taking, right? But that is not the nature. And because of this, obviously correct response time will not be shown in, because uh, this only took 9 seconds. Right. So total load time of login, is it 9 seconds? I reloaded it, but let it be. No, it's not 9 seconds, right? So how to do that? So this calls needs to be fired parallelly, means at same time. That is called parallel concept. So how we will do that? So for that we have a controller. Okay. So inside login, right click and go to controller and parallel control. This is a plugin. If you remember, we installed this parallel controller in our plugin, first controller. First plugin, first or second plugin, this was parallel controller basically. So it comes as a plugin, it doesn't comes by default. So whenever this kind of scenario will happen, you have to install this plugin and use this. Now we added, now all those asynchronous calls which are from here to here, we will control X and we'll put them inside parallel. So they are inside parallel. All is inside login transaction, fine, but login first three requests are synchronous sequence 1, 2, 3, but and below that parallel, and these are not synchronous, they are asynchronous, they needs to be fired parallel. So uh, now if I run it, now you see the time as well. So you see this got fired parallel. Now you see this got fired suddenly, correct? They got fired suddenly. Again, shall I run? These three, one after another, one after, now this suddenly, this three suddenly, this. So that is how it has to be, right? You can see the starting time. That uh, don't think it will change for much more than 1 second. It will never change. Do you see? It's first is at 22:854, and all are almost at that time. Correct? Maybe just 1 second gap will be there because these are so many. But I don't think more than 1 second gap will be there. No. They all got fired with that time, right? So this is how we will be handling. So this was the special case. Okay. Right. And um, here you can limit the max thread. Max thread means how many you want to fire them parallelly. You can limit it. And you can generate a parent sample also. Yeah. So it will be like parallel control parent sample inside that one. So so now this all took 153 seconds. Okay. And then we have separate these three, right? One after one. This is millisecond, 1.533 seconds, 150, 1533 milliseconds, right? So this is what I wanted to show you guys. That is a special thing about this scenario. Fine. Rest, adding assertion and all those things we have to do for every. That all thing is a part of the scripting. Only special thing was just understanding the execution of this asynchronous calls, how it impacts. Fine. Now, so we understood this. Now, so understood uh, epoch time or next time um, in a script, and it's in the real time. It's handled. Fine. Now we will go and talk about regular expression. So let us see how much we can talk. Okay. Fine. So regular expression. Now, regular. So regular expression, remember, is a very important concept, and it's not only in JMeter. It is there in everywhere. Like it's there in programming language as well. Every programming language has this concept of regular expression. Okay, and it's very important thing. We have to use that in performance testing also. Why we use that in performance testing? To extract the value. Right. So understanding them is very important. So expression is used for matching and extracting a string or value from response by giving contents and matching values. Right. There is a software pattern which is used by JMeter, which helps in doing this stuff. Okay. Now, in this, we will also understand like those dot plus question mark, why we use that, right? This braces I have covered. The braces represents the boundary, right? That I have covered, but what is this? Why we use them? These all symbols that you see are called meta characters. There are certain characters. So that character list is here. List of common characters. Uh, what meta- So these are all some meta characters. These are reserved. Actually, reserved means in normal world we call them as a braces, right, or a small bracket. Or this will be calling slash or anchor or question mark dot. But when it comes to programming language, they have some, or especially when JMeter or other thing, these all have some meaning. Okay, these all have some meaning, right? In programming language like slash t, tab, slash and new line, right? They have some meaning. So that's why they are called meta characters. Now we'll talk about them. Yeah. So this will come after on. So first, let us learn about this today. So I'll go to regex one. This is a website you can also refer to just practice some of the regular expression. Regex, regex1, one.com, regex.com. And when you open this website, you see on left hand side, right hand side, these characters are the meta characters which are important in regular expression with their meaning is displayed. Right? So you see ABC, digit, any non-digit, any character, period, right? Uh, Zero or more repetition, optional character, plus all this thing, they have the character and their meaning they have done. Now this is used to just learn or understand the regular expression. We do not need to know all those things. If you want to know more, only whole thing generally as a programmer when the programming people generally they can learn the whole thing. Right? For them, it is more important. For us, just understanding is more important, not whole thing. Right? So this character helps in matching the uh, uh, strings or value. Now here's some example. Is there? Suppose this is example A B C D, right? Suppose I want to match this, right? So if you see here, it's written all are, what is the pattern? First we have to understand the pattern, matching characters. So all are in A B C D, right? A B C D, A to Z, right? All are in A to Z form, and all are small, correct? So here you can see A B C, right? Only A B C, only A B C, or if you do A to Z, all characters will be coming. So suppose I want to match it. So if I write A, so it got matched. If I write B, C, D, E, F, G, H, like that, all got. So suppose I'm doing this, so this got matched, but these two are not got matched, right? And but suppose if I'm only doing one, so this is getting matched. Now, uh, now next thing is, uh, suppose this all will do here. Try to like write like what they are saying, square braces and ABC, right? So square braces and this all value. So when we put all those pattern of the string inside a square braces, that is called one group, a group, a group. So now this is whole thing is matching one. Now if I have to match all, I have to write it that many times, right? Like this. Suppose I'll write it three times. So three times, so these three got matched. Now if I write it five times, so this thing got matched. Now again, if I write, will be writing two more times, this will be. Now understand, if this is also not feasible way to write, like, because if you see our dynamic value, they are so big in nature, right? No. Um, okay, so if you see our dynamic value, anyone if you take the FP value, you see this is like, now suppose you want to match that using that pattern, right? Like this. So you have to write whole thing in one block, right? And then repeat that thing that many times, how much is the length of that string, right? Because if you see, suppose we have to match all these things. So all character we have to write in a block in one group, and we have to write that many times depending on its length. Then only it getting matched, right? So this is not feasible. So that time range pattern comes in picture. Suppose A to Z or 0 to 9, right? So instead of writing like this, we write like braces A to Z. So automatically will take okay all things between A to Z. Okay. So that's why you see first part. Now becomes the length stuff. So suppose this is three length. So I have to repeat it three times like this. Three times. This is okay. Now this is five length. So I have to repeat it 5 times. So this got matched. Now this is uh, 7 times. So I have to repeat them seven. Right? Okay. But again, this is also not feasible, right? That depending on length, how much time will repeat? Who will calculate the length of this? No one will able to calculate this. This one is so big. Who will keep on counting the stuff, right? So that's why we use a concept called plus or my star. Star is for zero or more repetition. So where zero is also considered, and plus is for minimum one and more repetition. So generally in our JMeter we use the plus, okay, not a star, because we need at least one value, right, while extracting. So minimum one we need. So what we have to do is, like, instead of writing all this, correct, uh, depending on the length, only we have to repeat, and repetition, you see, repetition, right? So either you can use a star or plus. So just write this much A to Z, and instead of repeating this that many time depending on length, after that if you use just a star here, so if you see all got matched, right? But as I said, in performance testing stuff, we do not use star, because star is for zero and plus is for minimum one, and we need one. So we'll go with plus, right? So we use plus. So when we do that, automatically you see length got handled automatically, right? We do not have to calculate, and how easy or how simple it became, right? So you got the idea uh, why we use the plus. Okay. Now we'll learn about a dot, then a dot plus. Fine. So let us go to continue. Yeah. Next, here also we'll try to learn. So like it's combination of, if you see, it the earlier was little simple. Now here, if you the strings, we have the combination of alphabets and then digit, or here also alphabet, then digit means the numbers, and some special character is there, space is there, and here also, right, a special character. Now suppose I want to match this. Then first thing is, as I said, that uh, we have to keep that like this, and repeat this. That means depending on the length, right? And writing this is also not good. So means not feasible, right? Who will always keep on writing like this? So we have to come with general approach. So general approach is like we have to first keep symbol and then A to Z, correct? A to Z. So A to Z will match anything between A to Z. So this. Now if you see in this string, number is there, right? Number. So number for that, it's 0 to 9. Okay. So after A to Z, in the same group, we'll write 0 to 9, like this same. Okay. Or you can just first tell you. So this is A to Z. Now suppose 3 times I write it. So you see all three got matched. Now here this is number. So we will write like 0 to 9, right? So first number got matched. Now we have, there are three. So I have to write it down 3 times, right? Depending on the length, like this. So these three got matched. Now again XYZ. So again A to Z needs to be repeated that many times. Right? So you see, very complicated and thing is happening. So better than doing like this, we create one group, and in that group only we put all the things, the range stuff that is coming. So instead of doing like this, we do it like A to Z and 0 to 9, right? And then braces close. So whatever you see there that you put inside a group. Now this will match always one character. Now to match all, we have to write this that many times, right? Length problem. So if you see, I have written this many times, so this got matched. But again, who will write that many times, right? Not feasible. So for that purpose, what came? Plus was there, right? Which we just discussed now. So this is the group that we prepared, and to multiply it by itself, right? Depending on the length, we use plus. So when I use plus, now you see automatically this whole thing got matched, right? Now we want to match this also. But in this, if you see only this is getting matched, this is not getting matched. And in this, there is third one, this is getting matched, this whole is not getting. So why they are not getting matched? Because if you see here, some special character is there and one space is also there. Or here also one special character is there, then equal to another space and space. So we have to add these special character in the group that we prepare. Okay. So first, let us say here after 0 to 9, we have quotes, right? So only one is enough. You give one quotes. So one quote included. Then there is a space, right? So give one space here. So see, I created one space. And this plus is for depending the length, right? So automatically do you see this already got matched because whatever the things are there, they are here. Now in this, whatever the things are there, we made a group of them, and then plus is for the length. Now this one is not getting matched. Why? Because here equal to is there, and number is there. So for number we have made already, but equal to is there. A space already we have given. So equal to and semicolon is extra. So here we can give uh, semicolon and equal to, semicolon and equal to. Also, we included that in group, and then uh, the space. This here I have given a space, right? So suppose I remove the plus, so always the first letter will match, and then I have to write this that many times to get see like this all matched. But again the length problem will, because this is extra more length with this, so this is getting unmatched. But it was happening, right? So instead of that is the problem. Instead of writing like this, we write plus so that the length problem gets solved automatically. Length of the string. You see now. So this same approach generally in interview we have to also make. Okay. So generally in interview, right, they can ask that suppose this is the value, this is the left boundary, and this is the right boundary, right? So prepare the regular. So we you will prepare like this, right? And this is very simple. Even a child can prepare like this, right? When a child can prepare like this. Okay. But they will ask you to prepare in A to Z format, which one I just told you. So prepare in that way. So first you have to read the string, right? That is the logic. Okay. So reading the string. So if you see, this is the string, yes, which is starting from here and ending here. Now, if you read this string, so in this string, first capital letter are there. So we'll be writing capital A to Z. We have to first make the group, where in group we have to put all the character coming in this script one time, right? So all character means all alphabets are there, capital alphabet here you see. So for them we one representative, one representative, correct? So all capital letters, so one representative, one A to Z. Then we have a small letters also, so one representative A to Z. Then we have number as well. You see, numbers are there. So one representative 0 to 9. Then a special character. So if you see hyphen is there and underscore is there. So we will put hyphen and underscore, right? So I'll prepare now. So like this, A capital A to Z, capital A to capital Z, then a small a to a small z, then 0 to 9, then hyphen underscore. Okay. So, so this so this is the group got. Now this is going to match this one, only one. Now this much is there, length problem, right? Now who will count and who will write this that many time? Not possible. So to avoid that length problem, we do plus. Okay. Now same way, let us say, uh, let us create A to Z format for this. So for this, try to first understand the string. So braces, then all capitals letters are there. So one representative A to Z. A small letter are there. So a small A to Z. Then numbers are there. So 0 to 9. And we have a special character. So if we see underscore, hyphen, and equal to. So underscore, hyphen, and equal to. So this is the expression. So let us type it. Okay. So I'll make it here. Capital A to capital Z. Then a small a to small z. Then 0 to 9. Right. Then underscore, hyphen, and equal. Right. So this is the group. Now group means what? Group will contain one representative for all the pattern, right? So all alphabet is one pattern, capital alphabet. A small alphabet is one pattern. Numbers are there. A special character. These are the special character involved. So one representative. Now this is going to match only first. Now this much are there, right? So to do that, we write as plus. Okay. So this is how. Now there will be question that why we do not practice this, right? Why we go with this, whether this works or not. So let us test it first. So I'll open our pet store application. So here, it may be any from anywhere. Let me just, okay. Test data is not. We'll open the recording. Now, this source page and API we are extracting from sign in, and we are passing here, right? So in sign in request, which is this one, I think it was 33 number we deleted, but it will be some here. Sign in. This is that request 34. So from here only we are extracting those values. This is source page ID, and it's extracting the value. Correct. Right. Now the question is like why you are using this simple way, why not that way, and whether that way works or not, right? So first thing first, let us prepare that. So this is the pattern we prepared, right? Now this is the left boundary, correct? So we'll put that. Okay. Done. So this is left boundary, right? Now from where the value start, we have to tell that, right? uh, from where the addresses start, or the separator. Separator is what the small braces. So here we have to give the separator as small braces, small braces, right? Then this pattern or expression that you put inside, and this part is right bound. Okay, from here to here. That is there, we know. So I'll copy that. Mhm. Now let us go and use it to test. Let us see whether it works or there's some problem is coming. So actually, I think mm, hyphen will underscore will go first. Hyphen will go first, and then underscore. Yeah. Hyphen will go first, and then underscore. Now, if you see, it is also extracting the value and properly both value match 1 1 and match 2 1. Generally, we need the same. So it's extracting, correct? So working. Now, for that FP also we can do. So this is the FP, the extractor, the simple one which we have used, and you see it's extracting the value, right? Now, let us extract the value using this approach. So first left bound. So this is the left bound, copy and put it here. Then braces for telling that from where the value is will start, and closing braces tell where the value ends, right? So that is the work of opening and closing. Now this expression will put inside this, and this part is right. That is there. Right bound to implement. This is the right. Now we'll copy this and try to test. So same match should come 0118 and UFA2, right? See, 0118 UF. So it's working. So in interview, they will ask you, they can give a value and they can ask you to prepare the regular expression in A to Z form, because this one a child can also write. This is very simple, but this is a little bit complicated and we need to understand and we need to explain also. Now, this is also working, correct? This is also working. This is also working. Or here, this was also working and this is also working. Then why we go for this, right? Why we go? That will be your question, correct? So let us go. There dot is the dot. Now what happens? See, to prepare a regular expression in this A to Z format for this value or for this, what you have to do? We have to spend time, right? Spend time in studying this value. That in this value, what are the patterns? All capital letter, all a small letter, or zero, hyphen, underscore, or here equal to is also there. That pattern we have to study, right? And then we have to make it. So time is being spent, right? Already we are spending time on reading left boundary, right boundary, and then a special time for this value to read and prepare that, right? So that extra time is there. Okay. So that is one drawback. Now another drawback is, which is more important, is suppose this is a value, okay, and here equal to is there, and you have given equal to in the pattern, fine. But next time when you are running in this value, instead of this equal to, that equal to is not coming and some other way, let us say and came or has came, but that has a stuff or the pattern for has you have not given here in the group, right? This is called group. So you have not given the pattern for or representative for has or and in the group because you do not know, right? Maybe here equal to, then next time something else came and that maybe and or has came and that pattern representative is not there in the group. That time will it work? It will not work, correct? Because that pattern is not there, pattern representative. So that is the biggest challenge, okay? Because dynamic value are changing in nature and anything can change, right? So that is the biggest challenge. So first thing was we have to read that and spend time. Second thing, if anything change and that representative for the changing pattern is not here, it will fail directly, it will fail, right? That is the biggest problem because these are dynamic value, they are changing value, anything can happen, right? So to avoid that, the dot comes. Now what dot comes? Let us say that uh, you have to match all this. For an example, suppose first you have to match this. So what you will do as per A to Z, this that is all in a small letter. So you'll write A to Z and then braces, square braces close, and then you'll give plus. But still it didn't got match because here one dot is there, right? So we have to write that here. Then now is it full green. Now forget about this one. This is something else that was showing tick tick. Ignore this part. Just focus here. So this is now full green, means fully got matched. Now I want to match this as well. So this is number, right? So we have to put that representative here, 0 to 9. Now you see this also got matched. This now now this is not getting. So we have to put the representative for them as well here. One representative, right? So right. So now you all three got. So you see, we have to read and spend time, right? And we have to make the group so that one representative of all the stuff should be here, and the length is multiplied by plus, right? So that means now to avoid this problem, the dot is there. Dot meta character. Dot means any character. Means anything is there that will be represented by. So it means that if I delete all and I give dot, so dot. So you see, one dot, the first thing got matched. Now, if I suppose if I write one more dot, okay. So see, everything got four. These are four. These are four. These are four. I written four dots. All got matched. Right? So for these also we can write dot 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 dot. But again, how many dot you will keep on writing, right? So that's why instead we will give one dot, and then one dot will represent one character. Now there is a length, right? So length will be represented by plus. But plus. So now you see dot plus. So everything got uh, represented, right? So fine. So our work is yeah. So our work uh, of understanding this is still here. So now I hope you understand that what is dot, right? Dot means any. Now instead of using this, we will be instead of like this group square braces and all this, we use dot and plus. So dot plus means any character, and plus means length, multiply depending on the length, right? So this will solve the problem. So when we give dot, we do not need to read what is there. Let it anything there dot, right? Plus, if any value changes, like as you said, or length changes, anything happens, question mark and whatever, who bothers, right? Dot is there. So dot plus, correct? You got. So we use dot plus and braces, right? Now the question mark. Question mark is for is an optional character which represents non-greedy. It's called non-greedy, and it says that generally match stop when first match succeed, right? 0 or 1 time, except new line. So what will tell that in one line, if that match is coming only one time, so stop there in one line, right? Suppose in one line, same value is getting repeated with same left boundary, right boundary two times. So it will just go and search for the first, okay, first line, first value. So that's why we use question mark. It can go to next line. That's why here except word is written. But in one line, only one value it will try to search. Okay. So that is why question mark we use, right? So now you understand that why we use dot plus question. Okay. What is dot? What is plus? What is question mark? Why? What is this braces? Right? And hope you understand that in interview they can ask to write a regular expression in this way. So you can now write. They can give a value and ask to write. And they can also ask you like why we prefer this, why we do not use this, or you can explain them that why we go with this, right? So just now I explained. So like that. Okay? So wherever the interview question will be there, I am always uh, uh, pointing out that that can be asked in interview. So this is how they ask from regular expression. One question can be asked like this. So this covers our regular expression. Okay. Now next is regular expression extractor. Regular expression, characters in regular expression, writing a regular expression, and what why we. Next is regular expression extractor and its section. So immediately we'll cover that also. Now in regular expression, I think I have covered all, but what is left, I'll try to cover. So this is regular expression, right? Extractor, regular expression. So you know already about this. You know already about this. You know already about this also, right? So this is covered. This is covered. This is grouping. By default, grouping is $1, but I'll sometime we can use multiple groups also, but that is not suggested. But I'll tell that tomorrow I'll cover that. Okay, let it be. But by default, generally, it will be always one group because I said this is one group, right? Just now. So that's why to represent that, we use group number. So one will be always there because always only one group is there. So $1 we. Sometimes we can go for multiple that, but that is not feasible. But I'll show you. Okay, show you tomorrow. Next, match. So in match number, there are different use cases, right? Uh, Either we can give 1, 2, 3. So it will pick for a fixed first value or second value, third value. Uh, we can give a random value as well, right? To extract a value between certain range. So yesterday only I have uh, like give in adapting it's very important, right? Or in petrol also I have shown that. We have also seen about zero when to use zero, correct? -1 and match NR is left. So that we will be covering here. Here. Okay. About so this will be use case of match number and template thing I will explain, but generally by default template will be dollar. Okay. Next thing is about fill to check. A fill to check is like same as response assess. In response assess, you know where you want to verify, right? Whether you want to verify text response means response body, right? Response body. If you want to verify response code or response message or response header, you check accordingly, right? So same way from this is there to from where you want to extract the value. So suppose you want to extract the value from response body. Generally, we extract from response body, right? So we use this. Suppose you want to extract a value from response header, we use this. From a request header or URL. Suppose you want to extract response code, you will use this. Suppose we want to extract response message, we use request header and URL. This is request URL. Generally, no one does because whatever request is going from there, you will not extract anything. We'll always extracting from response. So response body, response header. Generally, this is not used. This is completely not used. Sometimes you can use this, but I don't think we will. Then sometime response code or response message you can extract. Right. This is called response code or response message. This is the response code. This is message. Sometimes if message is displayed and you want to extract, so that time you can use that, right? What expression are used for them, I'll explain tomorrow. And apply to is by default main sample. Main sample means the main request, and sub sample means sub request. Okay. So everywhere you'll see this is there main sample and main request, and we have always main request. Subsample means sub request. Now, what is sub request? Means embedded resources. Suppose there is a request and then if embedded resources are retrieved. So if you want to extract from this, but generally we do not never extract from there. So by default, this is selected, right? So this is all about regular expression extractor. So what is left to discuss more is a little bit more on template and one use case left for match number, which is -1 or match. Right? Apart from that, it's all done. So uh, that all will be covering to template and thing. Now, uh, so I think already we are done for today. So tomorrow we will cover all this, and yeah, we'll be covering. Okay. So tomorrow will be fine. So see, sometime A to Z method is also used. Okay, I'll show you some example. It's not like that every time we have to go with this only. Sometimes we have to go with this also. When we have to go at all examples. So these all are use cases. If you know this simple 11 use cases or this 12 use cases, right? You can extract any value in any application. You have to just understand it. So that will be agenda for tomorrow. So see you tomorrow. Take care of. Bye.
Thank you. Bye.
Yeah, thank you.